In this video, I'm going to show how the computer algebra system Maple can be used to help visualize the bonds between the carbon and the hydrogen atoms of the methane molecule. So I start off with the plots and the plot tools. You can see all the different options that are available. And I'm going to define these four vectors here, which are mathematically correct from the center of a tetrahedron to the edges. So I go ahead and launch all those. And I do a display, and as you can see, when I go into this 3 dimension, I can rotate around, and these arrows will represent from the center of the carbon atoms to the center of the hydrogen atoms. In that figure, you can see the kind of has that tetrahedral shape to it. Okay, now I want to kind of illustrate the carbon and the hydrogens as spheres. So I'm going to define these spheres here. Push enter on all those, and I'm going to display. As you can see, I've got the big carbon molecule in blue with a transparency of 0.85, and I've got my hydrogens in green that are also transparency 0.85. If that carbon looks a little bit too big, you can always tweak the radius a little bit. So instead of using a radius of 8, I can make a display. Well, hold on a second. We'll get back to that in a moment. If I display all of those vectors and the 5 circles, I can see now the sphere, the 5 spheres and the 4 vectors are overlaid one another, and I can rotate around and see the carbon and the hydrogens as I rotate around. Okay, if that ball for the carbon, is too big in the illustration, you can make the radius a little bit smaller. So let's go to a radius of 7/2 or 3.5, and watch what happens now when I do the display of this new sphere. Okay, now that carbon does not show up as huge as it used to be, and you can rotate around and visualize the carbon-hydrogen bonds with the red vectors going between their centers. Okay, if I don't want the vectors and I want the transparency to stay the same, I can just do the display on those spheres. Okay, and so you can see the interaction between the carbon and the hydrogens at the same transparency, 0.85, that we've used. All right, what if we want these radii to be big enough to where all the way, the entire red vector has a sphere encompassing it? Okay, well, the way I set this up, this was a radius of 10. And I initially had 8 and 2 adding up to 10. And as you can see, the spheres were tangent to one another when they met. Okay, when I did the 7/2, 7/2 plus 3 was not equal, and so these radii are not tangent to one another. The spheres are not tangent to one another. All right, so let's make the radii 6 and 4, and let's go ahead and launch those and do the display. And as you can see, we've got a bigger display of hydrogen atoms and a smaller display of a carbon atom, and you can see the red vectors illustrating the bonds between the carbon and the hydrogens. Okay, and if I want to be a little bit less transparent, I can shrink this down to a transparency of 0.4, for instance. And when I do that, you can see that you can still see the red vectors. They just don't show up as prominently, and the colors on the carbon and the hydrogen show up. They're more dominant color. Now the transparency is a little bit lower. So that's how Maple can be used to visualize the carbon and the hydrogens and their bonds in the methane molecule.